Today we're looking at symmetry and functions, and in particular we're looking at two very specific kinds of symmetry known as even and odd. So symmetries can be either rotational or reflective. Rotational symmetry is symmetry about a point, and reflective symmetry is symmetric about a line. So we're going to have to be able to find those symmetries numerically, graphically, and algebraically. So those two types of symmetry that we're looking at, the special ones today, are called even and odd. Now, a function has even symmetry, or it is an even function, if and only if, when the point xy is on the graph of f, then the point negative xy is also on the graph of f. Now, what this looks like on a picture is that the graph is symmetric about the y-axis. And algebraically, that would mean if you put in negative x in place of the x in the entire function, you get the exact same thing as the regular function all over again. On the graph, that comes out as the y-axis acting as a mirror. So essentially, if you took the graph and you folded it along the y-axis, the left side of the function and the right side of the function would lie on top of each other. The second special type of symmetry is called odd, or odd functions. So a function is odd if and only if, when the point xy is on the graph of f, then the point negative x, negative y is also on the graph. That would make the graph symmetric about the origin. This one is a rotational symmetry. Algebraically, that would mean if you take all of the x's and you replace them with negative x, the final result would be that the function that you end up with would be the opposite signs on everything from the original function. On a picture, we call this symmetric about the origin. This would be if you take the picture and you spin it upside down about the origin, then the graph would look exactly the same, like this one right here. So here's the origin. If I took this graph and I put, like, say, a push pin there right in the middle of the graph, and then I spun the paper around that push pin completely upside down, the new graph would look identical to the old one. This piece up here would now be over here, and this piece would be up where the original positive part would be. That is what odd symmetry looks like. So now we have a few practice problems here. And this is just looking at the graphs and determining whether or not they have even or odd symmetry or neither. It is possible for a graph to have neither of these two special types of symmetry. They are special, so that means not every graph has them. So this would be a good place to pause the video and see if you can figure out which types of symmetry, if any, these three graphs have. Okay, welcome back. Hopefully you found that this first one was an odd function. It has odd symmetry because if you put a push pin right here in the middle of the graph and you turn the picture upside down, it would look identical as it did before you spun it. This second one, if you put a push pin here in the middle and you spin it upside down, it actually comes out looking very different. And if you use the y-axis as a place to fold your paper and you folded the graph over on that y-axis, the left side and the right side do not match up. So this one is actually neither of these two special types of symmetry. And for the third one, you put a push pin in the middle here and you spin the picture upside down, it would look like a very different picture. But if you took the paper and you folded it along the y-axis here, the left side and the right side would match up exactly. So this one is an even function, or it has even symmetry. Next up, we're going to be looking at these algebraically. So for algebraically, to test whether or not a function is an even function, you have to see if when you replace the x with a negative x, you end up with the same function as you did before you replace the x with a negative x. To test to see if it's odd, you have to replace the x with a negative x, so same starting process. And with that one, if what you end up with is exactly the opposite of the original function. Then it has odd symmetry. Okay, so to test for this, we're going to take each original function and we're going to replace the x with negative x everywhere in the function. And then we'll analyze the results that we end up with. So there are a few examples here that are completely worked out for you. The original function is given here at the top. In this first step for each of these, we're replacing the x with negative x everywhere within the function. So this x here in the function notation, as well as any x on the right side of the equation. So when we do that with this first one, we would then have to simplify. If you take a negative x and you square it, you would get the same thing as just a positive x squared, since anything times itself becomes positive. So this would come out as x squared plus 4, which is exactly the same as the original function. So that means when you put in negative x in place of x, you got the same thing as the original function all over again. So that makes this one an even function. For this second one, if we replace the x, here's our original function, replace the x everywhere in this function with a negative x. So here in the function notation, and also everywhere where you see an x on the other side of the equal sign. And then we simplify. So if I take a negative number and I multiply it times itself 3 times, so negative x cubed, I would end up with a negative of whatever the x cubed is. If I take a negative 2 and I multiply it by a negative x, negative times negative is positive, so that would make this one a plus 2x. And then if I factor out the negative, then I would end up with negative of x cubed minus 2x. So that would be exactly the opposite of what the original function stated. So that means f of negative x, when you replace the x with negative x everywhere within the function, you end up with exactly the opposite of the original function. And that's the hallmark of an odd function. For our third example here, our original function is given here at the top. To test for the symmetry, we're going to replace the x everywhere in the original function with a negative x. So this should actually say f of negative x. That was a typo. So replace the x everywhere within the function with a negative x. So this would say negative x squared. When you take a negative x and you multiply it by itself, you would get the same thing as just a positive x squared. Here we replace this x with a negative x, and then the calculation there would be a negative 3 times the negative x. Again, negative times negative is positive, so that would be the same as saying plus 3x. And then this plus 4 had nothing to do with x at all, so it's just going to get carried down with this step. Now, if I compare this result with the original one, I see the first term is the same, the second term is opposite, and the third term is the same. So this one does not have any kind of special relationship with the original function. So I would say that f of negative x is not the same as f of x, and it's also not the same as the opposite of f of x. So therefore, this one has neither of those two special types of symmetry. All right, so now we have a few guided practice problems here, and we're going to be testing these for that special type of symmetry. So the first thing I want you to do, because the first step in finding that special type of symmetry is finding f of negative x for each of these. So this would be a great place to pause the video and try finding f of negative x for each of these three functions, and then come back and see how you did. All right, welcome back. So when you make those replacements and you put in negative x in place of all of the x's, you should have put each of those negative x's in its own little set of parentheses for each of the three equations. And then you have to go about simplifying each of them. So in general, when you take a negative x and you multiply it by itself an odd number of times, so when it's raised to an odd power, your result is a negative of whatever it was before. So negative x cubed then. When you take a negative x and you multiply it by itself an even number of times, it's like the negative there didn't even exist. So this negative x squared is the same as x squared. Now I've got a positive times a negative here for this next term. Positive times a negative gives me a negative. And then that plus 2 on the end just stays as it is. So this would be a good place now to pause the video again and try simplifying the other two. Okay, welcome back. So with the second one, that was a little bit tricky because the negative x, when you square it, you get positive x squared. But then there was another negative in front of that. So that makes the final result there a negative x squared. The third one was pretty straightforward. It was a negative x times itself 3 times, so that would come out as a negative x cubed. And then the second term was a positive times a negative, so that comes out as a minus. Next up, we need to analyze the relationship here. So the first thing I want to do is see if it's an even function, and that would be by comparing this f of negative x to f of x. If they are equal, so if the result here is exactly the same as the original, then I would say that this is an even function. Now looking at these two here, they are not exactly the same. So therefore, I could say that it is not an even function. Next, I would want to compare this one here. I'm going to factor out a negative from the entire function there. So I'm going to take f of negative x, and I'm going to factor out a negative. So that would change the signs on everything here. That's going to make this x cubed plus x squared plus 4x, and then minus 2. And now I'm comparing the inside part here with the original function. And if those are exactly the same, then I can say that this is an odd function. Otherwise, I would say it is not odd. So because the signs don't match up exactly from this inside the parentheses here and the original function, I can say that this one is also not odd. So in my analysis, if I say that it's not even and I say that it's not odd, then I would have to say that this function has neither of these two special types of symmetry. Okay, for the second one, I'm going to again analyze. I'm starting with what I ended up with when I put in negative x in place of the x's. And if this matches exactly with the original, so if f of negative x is exactly the same as f of x, then I could say that it has even symmetry. And in comparing those, I do see that they are exactly the same. So therefore, I can say that these two functions, this function has even symmetry, that special type of symmetry, which means the graph of this function would be symmetric with the y-axis. So if I graphed it and then I folded the picture along the y-axis, the left side and the right side would match up exactly. Now, if a function is even, it cannot also be odd, so I don't even need to bother analyzing to see if this one is odd. Once I determine that it's even, I'm done. Now with the third one, again, starting my analysis by checking what I got for f of negative x against the original function. So I'm comparing this to the original function. And I see that they are not the same. So I can say that this is not even. That means this function does not have that special type of symmetry. So now I need to check to see if it's odd, because if it's not even, it could be odd. So to check for odd, I'm going to take my f of negative x. So I'm looking back at this step right here. And then in the resulting algebraic expression that I have there on the right, I'm going to factor out a negative, which will change the signs on everything within this expression. So that would say x cubed plus 4x. Then I would compare this inside part here with the original. And if they are exactly the same, then I could say that that means that f of negative x is equal to the opposite of f of x. And they are. So that means this one has odd symmetry, which means the graph of this function, if I put a pushpin in the origin and I spun the paper around completely upside down, it would look identical to the original picture.